Hey guys, Mr. Bradley here, and in this video we're going to go over what are measures of central tendency, data analysis. It's kind of an intro to our first unit, data analysis, and we're really going to look at measures of central tendency. We're also going to intro one of the measures of central tendency. I'll have Mr. Stewart do that towards the end of the video. So first, let me give you kind of an example of what this was like and what would we use data analysis for. So here I have three people. I have Bob, Donna, and Jason. And let's say that these three people competed in a video game on their iPads for 5 days in a row, and they calculated their scores at the end of each of the 5 days, and they recorded them on this table. So here I have Bob's scores for each of the 5 days, I have Donna's scores for each of the 5 days, and then I have Jason's scores for each of the 5 days. So just looking at the numbers, I might say, hey, which of these players was the best at this game? Now, how do you make an argument? You can't just look at Donna and say, I think Donna's the best. Why? Because her numbers look pretty good, I guess. That's not a mathematical argument. So you need to learn how to use data analysis to make arguments over things like, well, who's the best player at this game if these are the scores? Now, if you want to get real basic, you could look at it and say, I think that Jason is the best because he has the highest score. He had a 110 on day 3. The other two players never scored that high, so Jason must be the best at this game. Well, that's an argument, and it does use a data point. You're using what's called the maximum. You're saying, well, he's the best because he had the highest maximum. But that ignores all of the other facts, because Jason did have the highest score, but he also had the lowest score. He's the only one that had scored 80. Nobody else scored that low. So is he the best? Now that's when we're going to use data analysis, okay? Now here I have them plotted on dot plots, and you can kind of see them side by side, and I might ask you, hey, who's the best player if you see their scores? Like here's Jason's 80, and there's his 110, and you can see his other games, and these players both had 95s, and Bob had a 105, but Donna, she didn't have a 105, but she also didn't score as low as Bob. So who's the best? How can we compare these? And that's when you're going to want to use what's called measures of central tendency. Measures of central tendency are ways to see what's typical for Bob. What does Bob usually score? What's typical for Donna? What does she usually score? And we're going to look at the 3 measures of central tendency in this unit. In this video, we're first just going to introduce what's called median. So let's talk about that next. All right, now to calculate the median for these 3 players, I'm going to give you a crash course, and then Mr. Stewart's going to take you through the examples on your homework. So first, if we're going to calculate the median, that's the middle value if we put the numbers in order. So first thing I did was I took Bob's scores and I started with his worst score and I ordered them up to his best score. And then I did the same thing with Donna, lowest score to highest score, and I did the same thing with Jason, lowest score to highest score. So now all we have to do is find the middle number for each of these. This data set's really small, it's only 5, so it's pretty easy because the middle number is the 3rd number. But you might want to start by just after you order them, you can cross off 1 from each side until you eventually end up with 1 in the middle. So Bob's median score was 95, and Donna's median score was also 95, and Jason's median score was 90. So while Jason had the highest score, his median score was actually lower than the other 2 players. So he's actually maybe not as good as those 2 players if I want to use that as an argument. Now median's easy when you have an odd number of data because you're always going to have one number in the middle. Mr. Stewart will show you what to do when you have 2 numbers in the middle and there's an even set of data. Take a look.
All right, today we are going to find the median value of the data set. Remember, median means the middle term and we're gonna look today at finding the middle term of two different amounts of data sets. The first one we're looking at is an odd amount of data. So step one, you should arrange your data in order from least to greatest. In doing this, I will begin by picking off numbers and canceling them out as I write them down. 53 being the lowest value. Goodbye, 53. And then work my way. 62. I want to make sure I'm not missing any values as I go through this. 65. 67. 70. 71. 78, 82, and it looks like I have one left with 92. Now what I notice with this, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 values, being an odd amount. So I want to find the middle right now. To do so, I will count in each way till I get to the middle number. 1 and 1. 2 and 2, 3 and 3, 4 and 4, and right in the middle value being 70. Let me just double check to make sure I'm sure. I have 1, 2, 3, 4 values, 1, 2, 3, 4 values, and right in the middle is our 70. Finding the middle number. So the middle number is 70, meaning that the median is 70. Now, our next problem, we're going to be looking at a data set that has an even amount of numbers. So I will begin absolutely the same as before. I will begin to lay out my values from least to greatest, organizing them and crossing them off as I go. I have 7 first, then I have 9, 18, 26, 33, and 42. Good, everything's been crossed off. So next, I have 1, 2, 3, 4, 5, 6 values. It is an even amount. If I tried to find the middle, it could get kind of difficult. 1, 2, 3, 1, 2, 3. I'm right in the middle. Look at this, 1 and 1, 1 and 1. I have 2 left. I have 18 and 26. Man. Now, the next step is I have to find what would be in the middle of these two, in the middle of 18 and 26. I'm going to find the middle. Right now, I know that between them are 18 and 26. So I'm looking for a value that is located between 18 and 26. To do so, the next step is I have to find the average of the two numbers. To find the average, I'm going to add up the two numbers and divide them by 2. By doing that, I'll end up finding what is perfectly in the middle of 18 and 26. So let me begin. 18, 26, 6 and 4, 14. A little regrouping there. 44 is the total value of those two. I'm going to take those all together and divide them by 2, divide them in half. And if I do so, I end up with 22, the median value of 22. We just looked at 2 different examples. Down here we are dealing with an even amount of numbers. And up above, my favorite, odd, just find that middle number and you're done, right? And that's it, guys. See ya.